यहाँ पर 3 वेक्टर दिया हुआ है और बोला हुआ है कि वो वेक्टर्स कोप्लेनर है. We have to find out the value of lambda. Since the 3 vectors are coplanar, already we have learned that their determinant must be equals to 0. So we can write over here, that is 1 minus 1 1 3 1 2 1 lambda minus 3 must be equals to 0. From this we can easily find out that lambda equals to 50. Next question, we have to prove this equals to this. So first let us solve this. This can be solved as A cross. Here we can write here B cross A vector, B cross A vector plus B cross 2B vector plus B cross 3C vector. Then we can write here plus C cross A vector plus C cross 2B vector plus C cross 3C vector. Now we can see from here that this portion becomes 0, then this portion becomes 0. So we get here A vector from here we get here So from here again we can see that this portion is equals to 0 and this portion equals to 0. So from here we get 3ABC, 3 and here it is AC2B. We can change the sign, so we can get it here minus 2AB cross C, which is equals to A vector, B vector, C vector equals to RHS. Show that the 4 points A, B, C, D are coplanar. तो 4 points को coplanar दिखाने के लिए पहले हमें क्या निकालना होगा? 4 वेक्टर्स जो यहाँ से निकलती है, यहाँ से जो वेक्टर्स निकलती है पोजीशन वेक्टर्स के हिसाब से अगर हम निकालेंगे तो यहाँ पर सबसे पहले हमको ए बी निकालना पड़ेगा. So here a b equals to 0 minus 4, that is minus 4 I cap, minus 1 minus 5 minus 6 j cap, minus 1 minus 1, that is minus 2 k cap. Next we have to find out AC vector AC, that is 3 minus 4 minus 9 minus 5 plus 4j, 4 minus 1, that is plus 3k. Next we have to find out AD vector equals to minus 4 minus 8 I have 4 minus 5 minus j plus 4 minus 1 is 3k. Now if we have to find out the det, if the det of this is equals to 0, that means the points are coplanar. So let us find out the det here. We write here minus 4 minus 6 minus 2, then we write here minus 1 plus 4 plus 3, then we are writing here minus 8 minus 1 plus 3. So from here expanding this, we get here minus 4 into 4 is 12 plus 3 15 minus of minus 6, that is plus 6, this changing this, that is minus 3 plus 24, minus 3 plus 24 is plus 21, then writing minus 2 plus 1 plus 32. This equals to minus 60 plus this is 33. Hence the det is 0, therefore the 4 points are coplanar. Let us take the left hand side this question. This implies that A vector dot B vector plus C vector cross D vector. This can be written as A dot B cross D vector plus dot C cross D vector. This is equals to A vector comma B vector comma D vector plus A vector comma C vector comma D vector. Proved. To prove this part, if the vectors A, B, C are coplanar, prove that these are also coplanar. So to prove this part, let us prove it conversely, and let us suppose that these vectors are coplanar, then we'll prove that A, B, C are also coplanar. So let us assume that these are coplanar. So we can write down here vector A plus vector B plus vector C cross C vector plus A vector equals to 0. This implies B cross C plus A, that is we can write down here B vector cross C vector plus A vector plus C cross C plus A vector equals to 0. So let us assume that A vector plus B vector, B cross C plus B cross A plus C cross C plus C cross A equals to 0. Now we can see that this is 0. So we can now assume that B cross C, B cross A, C cross A. So we can assume that A vector dot B vector cross C vector plus A vector into this is 0, A into this is 0, this is also 0. Now let us go with B dot this, which is also 0, B with this is also 0, then we get here plus B vector C vector cross A vector equals to 0. So from here we can write down here A, B, C, then 2A B cross C vector equals to 0 implies A vector dot B vector cross C vector equals to 0. Hence A vector, B vector, C vector are coplanar. So we have proved the converse of it, and the converse of this also can be proved very easily. This is one more important question which has been repeated many times. So we have given this. So from that we can write down that cross A vector plus B vector plus C vector equals to A vector cross 0. So from here we can get A cross A is 0, we get A cross B vector plus A cross C vector equals to 0. From here we can see that A cross B vector equals to C cross A vector. This is 1. Again, taking vector B cross A vector plus B vector plus C vector equals to vector B cross 0, which implies vector B cross vector A plus vector B cross vector C equals to 0. Vector B cross vector A equals to vector C cross vector B. So this can be written as vector B cross vector A cross vector B equals to vector B cross vector C. A cross B equals to C cross A cross B equals to C cross A, and B cross C equals to A cross B. So from 1 and 2, vector A cross vector B equals to vector B cross vector C equals to vector C cross vector A. Now we have to prove here that vector A, B and C here is equals to 0. Now writing this part here, this can be written as this. So here we get we know that B cross C is equals to A cross B. So A cross B vector which is equals to 0, hence proved. Here in this question, the three vectors are given over here, and the question is C1 equals to 1, C2 equals to 2, find C3 if A, B, C vectors are coplanar. We know that if A, B, C are coplanar, then the determinant is equals to 0. That means what we can write down here 1, 1, 1. Then here write 1, 0, 0. Then we can write C1, C2, C3. This must be equals to 0, which implies that from here we get C2 minus C3 equals to 0. But we know that C2 is given 2, therefore 2 minus C3 equals to 0 implies C3 equals to 2. Our first question has been proved. This is the second part of this question. Already in the previous question we have done that ABC is if they are coplanar, then ABC equals to C2, det of ABC equals to C2 minus C3, which is equals to minus 2, and minus 2 cannot be equals to 0. Hence, no value of C1 can make ABC here coplanar because we don't have any C1 over here. This is one more question, that if vector A, B, C are unit vectors such that the given here the criteria and angle between vector B and vector C is pi by C, then we have to prove this. Okay, so this can be written in the format of this on simplification, and further on simplification we get here 2 into vector A scalar product of A, B, C, since this is equals to this. So finally we get 2A vector into this B cross C is equals to plus or minus half of A vector, which already we can prove from here, and also I have proved in my YouTube shorts. So I didn't prove over here. You can go through my YouTube shorts as well, and finally we get the result. This portion, it is in my